So far in this section 6.5 on multiplying polynomials, you have multiplied monomials together, one term times one term. You've multiplied monomials times any polynomial using the distributive property with your exponent rules. And now in part 2 of section 6.5, we are going to multiply binomials by other polynomials. So for example, you see in example 1, we have y minus 3, which is a binomial, and we're going to multiply it by another binomial, y plus 5. So what your method is going to be is to use the distributive property not once like we did before, but twice, and then as you did before, combine like terms if you have any. So here's what I mean by the distributive property. In this first binomial, y minus 3, there's a y and a minus 3. You're going to separately distribute the y to the second parentheses, and then separately from that, distribute the negative 3 to the second parentheses. So what you're going to do is you're going to take y and multiply it times y. So y times y is y squared. Then you're going to take that y and multiply it times 5. So you're doing the distributive property with the y here, and you're going to get 5y. Then, once you have distributed the first term in the first parentheses to the second, and notice I wrote that down, once we've distributed that y to everything, we're going to switch to distributing the negative 3 to the second parentheses. So I'm going to take negative 3 and multiply it times y, which gives me negative 3y. And then I'm going to take negative 3 and multiply it by 5, which is going to give me negative 15. And then once you've done your two distributions, your last step is going to be combine like terms. At the same time that I combine my like terms, I'm also going to, if I can, if there's only one variable, I'm going to remember to write my answer in standard form, which you should always be in the habit of doing. So there aren't any other y squared, so I'm going to put my highest power first. But when I look at the y's, I see a 5y and a negative 3y, which gives me just positive 2y. And then there are no other constants, just the negative 15. So I write that, and here's my final answer. It's a quadratic trinomial, y squared plus 2y minus 15, and you're done. Next, we're going to look at a couple of other situations of this same type of problem. In our second example, we have the same thing, a binomial times a binomial, but there's two variables in it. However, we're still going to do everything exactly the same way. I'm going to take my first term in the first parentheses and distribute it to this term, which gives me 5, and then it's going to be a to the 4th because it's a to the 3rd times 1a. I'm going to distribute this first term to the second term in the second parentheses. So that's 5 times negative 3 makes negative 15. And then there's an a cubed, and there is a b squared. Once I'm done with that, I'm going to move on to the second term in the first parentheses, and I'm going to distribute that. So that's going to be negative 2, and then there's just a single a and a single b. And when I distribute that to the second term in the second parentheses, I'm going to get negative 2 times negative 3 is positive 6. And then there's a b and another 2 b's, so that makes b cubed. And in this one, there are no like terms, and there's multiple variables, so I don't need to worry about standard form. So I can just write 5a to the 4th minus 15a cubed, b squared minus 2ab plus 6b cubed. And if this was in a different order, that would be okay. Here's our answer. This is a polynomial, and we won't talk about its degree because it's got more than one variable. Next, we'll take a look at a similar problem that's just written in kind of a tricky way. In this example, I've written 2x minus 1 squared. So this is something you want to watch out for. Sometimes when the two binomials being multiplied are the same, you'll write the original problem with an exponent. Because what you want to remember is that 2x minus 1 squared, that means there's two of them. So that's really the same thing as 2x minus 1 times another 2x minus 1. So the first thing you want to do is rewrite this without the exponent. Once you do that, it's business as usual. Take the first term and distribute it. So 2x times 2x is going to give us 4x squared. 2x times negative 1 is going to give us negative 2x. We switch to the second term. Negative 1 times 2x is going to give us negative 2x. And negative 1 times negative 1 is going to give us a plus 1. You want to watch out for switching that sign. We're going to combine like terms, and so there are no other x squareds, so we'll have 4x squared. There's a negative 2x and a negative 2x, which gives you negative 4x, and then there's only one constant plus 1. So I wrote that with all my like terms combined in standard form. We're ready for our last example. In this one, I'm throwing a binomial, two terms like 3x plus 4, times a trinomial at you. Looks a little bit different, but it's the same method. The only difference is that there are 3 terms over in the second part, but we're going to do the same thing. We're going to take the 3x, and we're going to distribute it to the x squared, which gives you 3x cubed. We're going to take the 3x and distribute it to the negative 5x, which gives you negative 15x squared. And then instead of being done and going to start distributing the 4, we just have to distribute the 3x one more time. And so 3x times 2 is plus 6x. Now we're going to move on. Now that we've distributed the 3x to everything, we're going to distribute the 4 to everything. So 4 times x squared gives me plus 4x squared. 4 times 5x, negative 5x, gives me minus 20x. You want to make sure that you watch out for that negative there and keep it with it. And 4 times 2 gives us a constant 8. So now we'll combine like terms, starting with the highest power. We have a cube in here, so that's the only one. That's 3x cubed. I've got a negative 15x squared here and a 4x squared here. So adding those together gives me negative 11x squared. I've got a positive 6x and a negative 20x, which gives me negative 14x, and then just one constant, positive 8 on the end. So although this was a little bit bigger, it was the same method. Distribute everything in the binomial to everything in the trinomial, combine like terms, and you're done. And we're also done with this video.